Hello and welcome to everybody in the audience. Today we have a very exciting event. We have the minting of our first IP-NFT with Rodrigo Ledesma-Amaro. So we have him and we also have Albert here to talk a little bit more about the project and why we're so excited to fund it. So without further ado, I'm going to introduce Albert, who's going to tell you a little bit more about ValleyDAO and what we're doing. And then we're going to bring in Dr. Rodrigo Ledesma-Amaro to talk about the project and what it hopes to achieve. So welcome to you all, and thank you for being a part of such an exciting event.
Yeah, thank you so much, Morgan. Thank you. Yeah, it's a really exciting day, something that we've been working towards for almost 1 year. Before we get into the project, of course, my name is Albert. I'm one of the core members at ValleyDAO. And to me, ValleyDAO really is what open science did for research. ValleyDAO is doing that for funding and translating larger scale academic research in synthetic biology. We are creating avenues for anyone in the world, synbio enthusiasts, researchers, entrepreneurs, investors, to come together, pool their networks together, pool their resources and their capital together, and collectively source, evaluate, and fund the synthetic biology climate research that they think will set the foundations for the future of this industry. Imperial College London has been that university that has, together with us, pioneered this model that we've been leveraging and applying to this particular project. This project was funded collectively through the community. So we recently closed a round of funding, and that came from all sorts of people from all over the world. And I just think it really says a lot about what we can accomplish when we all come together. And now we're funding quite a big 2-year project at a leading synthetic biology university, and this is something we want to continue doing as we move forward with ValleyDAO and grow the community even further.
Absolutely, thanks, Albert. And so the reason we brought you here today is obviously to meet Rodrigo and to find out more about the project. So without further ado, I'd like to introduce Rodrigo. So first of all, just going to take you through a snapshot of his career. So he's got not one, but 2 bachelor's degrees, one in biotechnology and the other in chemical engineering. He did his master's at the University of Madrid in microbial biotechnology, a PhD at the University of Salamanca, where he was working on metabolic engineering of Ashbia gossypi for the production of vitamins, nucleosides, and lipids, of which there were numerous papers and industrial patents produced, some of which are in use by BASF. He also received the Marie Curie Fellowship and studied a postdoc in France, where he primarily worked on the metabolic engineering of Yaroia lipolytica. So currently he is an associate professor, just promoted, I think, last week, in the Department of Bioengineering at the Center for Synthetic Biology and Innovation at Imperial College London. So Rodrigo, could you tell us a little bit more about the project and what it's hoping to achieve?
Sure. Thanks for the introduction. Hi, everyone. Yes, so the project is kind of based on the line of research that you just mentioned, right? I started working with lipids during my PhD in filamentous fungus. Then I continue working with lipids in Yaroia lipolytica, which is the model yeast to do so. And then I continued at Imperial College setting up synthetic biology tools on how to engineer this organism for further applications. So the project is about lipid production, and the project is about doing this in yeast cells. And why do we want to do this? So because we're trying to replace products that are similar to oil. So one of them is fossil fuels. They can be replaced with biodiesel. With biodiesel, it's basically plant lipids, but plants are not sometimes as sustainable as we would like to, since we need to use like a lot of land and water resources. And linked to plants as well, another oil lipids that we are used to consume is oils for food. So we all are familiar with palm oil or sunflower oil, and we use a vast amount of them to feed ourselves. And by producing microbial oils, we can get around all the hassles, environmental issues of working either with plants or with petroleum, and have a more sustainable alternative to do so.
Amazing. And so, Albert, I'd love for you to introduce a little bit more about how ValleyDAO is interfacing with Rodrigo and Imperial College, and why it's so important that we're doing it in this way rather than going the legacy funding route.
Yeah, no, I think it's pretty straightforward. I think with if this project was funded through traditional means, it would be a grant funding agency providing the funding and then expecting some sort of publication, and that's it. And traditionally being very on the sidelines, waiting for things to happen. With ValleyDAO, we're bringing in a community of experts, of other types of professionals, of researchers, of entrepreneurs who've done this in the past, and we can already at early stages of the research, already there figuring out not only how we're going to do this in the lab, but also how we can bring it to the next step before Rodrigo and the postdoc that we will be working with even enters the lab. So it's de-risking it at the early stage, making sure that there is a so-called product market fit before we spend this capital, so that we can always ensure that every dollar that goes into research also has an impact. And yeah, that's kind of like the way that we're looking at it. We've assessed the IP potential, so through the help of other community members who have experience in this, to ensure that whatever is generated here doesn't have any prior art, that is innovative and has the potential to really move the needle in terms of scaling up these manufacturing processes for lipids. We've already had some industry validation. So we've talked with 2 companies in this space who I cannot mention, but they've stated an interest in this technology. And I believe a lot more companies are going to have an interest in this because it can really decrease their production costs, which is the main bottleneck in this whole industry of producing bulk compounds. And then I think also, as this project evolves more and more, and as research results come out, is to continuously match it with interested stakeholders, and already see what if there's potential to spin something out internally through the DAO. And if that's the case, we can quite efficiently assemble a team, develop a business model, and start raising additional capital on top of that. And I think all of this can be enabled through just the sheer amount of network effects that are being enabled through organizations like DAOs, like ValleyDAO, like VitaDAO, like LabDAO, all of these decentralized science entities that have popped up in the last 2 years.
Absolutely. Thanks, Albert. And Rodrigo, I think I've got a few questions here that I'm sure the audience are burning to understand. So could you tell us a little bit more about the impact that this project could have on the planet if successful, and maybe highlighting some of the application areas of a technology such as this?
So I think sustainability is the main driver of this project, and by replacing these fossil-based fuels or these food oils by a sustainable means, I think that's the main impact, right? We can help, if you want, stop or reduce deforestation by all those forests and rainforests that are being cutting down just to grow more palm trees, for example. It can, of course, reduce the CO2 emission associated with all of petroleum-based technologies, and we will produce this using microbes. Also, microbes have the capacity to use waste as nutrients, so you can think about not only producing something of interest that is in a cleaner way than other means of production, but you can also actually reduce pollution and waste, because you can imagine using like food waste, agricultural waste, industrial waste as a input stream towards the production of the final lipids.
Excellent. And perhaps you could tell us a little bit more about some of the technical and economic challenges that this project is hoping to overcome, both from the traditional way of producing these lipids, but also compared to other state-of-the-art lipid production, like biomanufacturing as well?
Yes. So I guess the core technology is thought to help what Albert was mentioning, the downstream process of this production of lipids. And so how traditionally this is done is you grow your biomass. It can be plant, it can be microbial, and lipids accumulate inside the biomass, and then you need to break down the cells to extract the lipids. And that process can be quite costly, depending on the organism you're using and the thickness of the cell wall or the composition of the cell wall. It will be more difficult to break those cells up to extract those lipids. And that can be done using energy, like mechanical means to disrupt the cell. You can use enzymatic reactions, but then you need also like energy to produce those enzymes that are quite expensive to have to process. And contrary to that, what we are planning to do is to make a strain, an organism that can give us away the lipids. So instead of accumulating these lipids inside the cells, they naturally secrete them out. And this simple idea can have a huge impact in the biomanufacturing and extraction process, just because then you don't need to produce as many cells, for example. So imagine, I don't know, we want to store something, or we produce something that can need to be stored in a house. The only way to produce more when the house is full is to make other houses. So we need to spend resources in building houses as well as building the product to fit in those houses. But if we can produce something that doesn't need a house to be stored, can be put outside the house, then we reduce the associated cost to making those houses to store the product. So that way, by secreting these lipids outside the cell, we can reduce the cost. We need less cells to be made, and more of the input nutrients can be actually made for the final product, which is the lipids.
Excellent. I love the metaphor of full houses. That's really great illustration of the point. One last question for you, Rodrigo. Why do you think that what do you think that you bring to the table in this particular project, and why do you think that you are the expert to take it forward?
Well, I guess the things we've been doing in the lab for the past 15 years, not only in my lab, but in the labs where I was previously. So I've been working on lipid metabolism for a long time, and in yeast genetic engineering, developing new synthetic biology tools to engineer organisms faster and more efficiently. I guess all that come together from a technological point of view, having those tools, those resources, and from a end product point of view, which are the lipids, is something I'm also been working on. So that come together as new tools with the product I'm familiar with, and now trying to combine those two things to make the project happen.
Amazing. Really excited for this to get underway. And as we've mentioned, this event is significant, not just because of the nature of the project itself, but also because of the way in which we're funding and translating this work. Albert, you've looked in depth into the business case for this project. What opportunities do you think exist for collaborations across the different verticals? And how do we hope to leverage this new IP-NFT framework to expand on the impact that this particular project can create?
Yeah, I think the big opportunity here is that what is being developed it's a platform of some sort, in my view, that can be customized and tailored to different niches, to different applications, to different end products. When it comes to fatty acids, it can be everything from cannabinoid precursors to food oils to fuels to cosmetics. So the types of markets that can be addressed here are quite many. As the intellectual property and the data comes in and starts maturing, it becomes more and more interesting to reach out to industry and really assess their needs and how they could see themselves applying this. If it can cut their cost by 20%, 40%, 60%. And really, I think as more stakeholders start becoming interested in this, and you maybe have 10 different companies interested in this, given that it's a platform, it has very horizontal applications, the IP-NFT framework makes a lot of sense here, because as it allows us to bridge this intellectual property into a blockchain where it can be programmed, it can be fractionalized, and a lot of things can be automated. And it could be as simple as if one of these 10 stakeholders wants to license it and start using it, it can be done through a click of a button. We don't have to have a bunch of meetings, a bunch of discussions prior to this event is happening. The only thing that will be needed from our side and from ValleyDAO's side is the alignment from the community of wanting to work with this particular stakeholder. So basically we would have a vote by the community, a outlined collaboration proposal that would be reviewed and voted on by the community to always ensure that whatever ValleyDAO does is in alignment with the same people that are bringing in their resources, their capacity, and their funding to the table, so that we can, really ride this ship together and ensure alignment at every step of the process.
Excellent. Now, Rodrigo, I know that you're a very busy man, and if you needed any proof of his ability to deliver on this project, he's going to have to jump very soon. So he's very busy. One last kind of question for you. Why should a synthetic biology researcher like yourself choose to work with ValleyDAO from your own perspective?
I think the best reason is the community, right? I guess it has been quite a great experience to be able to shape this project together with the ValleyDAO community. So it's not only me coming with an idea and getting or not getting funding. It was a conversation. So the project was initially proposed and then discussed, and the community gave feedback, and we kind of tune a little bit the project to de-risk it in early stages, or something that doesn't actually happen with any other funding source that I've worked with. So that was really good, and as Albert says, that's going to continue throughout the project. So it's not going to be me and the person in my lab working on this particular project. We're going to have support from the community, from ValleyDAO, from experts, from different aspects and different steps in the value chain that can maximize the impact of whatever comes out of this.
Thank you so much. And I'd just like to close by saying thank you to both of our guests, Rodrigo and Albert, of course. And just leave you with a final few words. So if you are a synthetic biology researcher or working in biotechnology or something that you think is going to benefit the climate, then absolutely, we want you to get in touch with us. We'd love to hear about what you're doing and see how we can support your work. If you want funding from us, you can simply go to our website where you'll find the research application form. It's just a few clicks away. It takes just minutes to complete. And it's much easier than a traditional grant writing process. So yeah, I implore you to fill out the form, get in touch with us, and you'll be in touch with one of our amazing community members who will guide you through the next steps. Albert, anything final to say?
I want to thank our amazing host, Morgan. Thank you for curating this conversation. I also want to give a call to action. So if you're from, in industry, in the industrial biotech industry, and you need support in optimizing your downstream processing and potentially be interested in this project, don't hesitate to reach out to us. We would love to have that conversation so that we can build something that is for you, that you can utilize as soon as it's finished. So yeah, that's my call to action. And yeah, thank you so much also, Rodrigo, for joining us and joining us in this journey.
Thank you, my pleasure.